Hello, here we are again. Just going to do a bit about the binomial distribution. There should have been a link just above for you to read through just to see where it comes from. This is linked from your GCSE kind of probability work, tree diagrams and things like that. Now, the important thing about the binomial distribution is how to spot one, and these things have to have certain properties in order to be able to be a binomial distribution. So the first thing is that they have to be independent events. So something like tossing a coin, the probability of tossing it the second time doesn't depend on what you got the first time. So as long as things kind of don't depend on other events, then that's okay. So as long as they're independent, again, like rolling dice maybe, then just because I've rolled dice 4 times before, then it doesn't affect the probability on the 5th time. It would still be maybe a 1/6 of getting a number on one die. So that's important, that they have to be independent so that they don't affect anything else, any other event. There can only be 2 possible outcomes, so that you can either basically have success or failure. So something like rolling a die, then you can either get a 3 or don't get a 3, or tossing a coin, you either get a heads or a tails. So maybe if you're trying to hit a target with a dart or something, then you either hit or you miss. So there can only be 2 possible outcomes like that. The other thing is that the probability of success must be constant. So something like flipping a coin is always a half is the probability of getting ahead. The one thing that I have missed out here is that there also needs to be a fixed number of trials. Because you'll have to maybe be flipping a coin, I don't know, 20 times maybe, and you want to see, oh, what's the probability of me getting 12 heads if I flip it 20 times. So if x, which is whatever it is that we are measuring, maybe it is the number of heads that we get when we flip a coin 20 times, then we write x as a binomial distribution, that tilde, that little squiggle, b, and the 2 parameters, or the 2 properties that we have are n and p, go in brackets like that. So this here represents that we've got a binomial distribution. This here, n represents the number of trials, so the number of times that I'm going to flip a coin. And p represents the probability of success. So it's the probability of me getting the thing that I'm measuring. If it's maybe getting a 2 when I'm rolling a dice, well, the probability of getting a 2 is a 1/6. So we will put a 1/6 in there. So yes, as long as we have these properties for a fixed number of trials, then we can say, okay, this event has binomial properties, so x has a binomial distribution. We then have a couple of options as far as how we can calculate probabilities. So let's just say I'm measuring whatever the probability is. I roll a die, an individual die, I roll one 10 times, and I'm looking at how many times can I get a 6 maybe. Well, the probability of that is a 1/6. So if x here represents me getting a number 6 when I roll a die, and I roll it 10 times, and maybe I want to know, oh, what's the probability then of me getting exactly 5 6s, getting a 6 5 times? What's the probability of that? Well, there's a formula for this. Again, you can see where this comes from the website, and it's given by n choose r times p to the power of r times q to the power of n minus r. Now I'm using q there to represent. The probability of failure, so the probability of not getting a 6. So all this formula says really is, right, fine, this is the total different number of combinations that you can get. 5 6s, you can get it first time, you can get it second time, third time, fourth time, fifth time, and then not get a 6 for the other 5 times. Or you can get it the first time, the second time, the third time, the fourth time, don't get a 6 on the 5th row, but then you get a 6 on the 6th row, then you don't get a 6 for the rest. Then you've got to think of all those different combinations. That takes care of it for you. And then because they're independent, then you multiply the probability of getting a 6 however many times. In this case it'll be 5 times, because that's my R. And then for the other times, well, you won't be getting a 6, so Q represents the probability of not getting a 6, which is 5/6. So if I wanted to know my question, the probability that X is 5, then I would have 10, I would have 10, because that's the number of times I roll the dice, choose 5, times a 6th to the power of 5, times 5/6. For the rest of my rolls, there'll be 5 left there, because I want to succeed. I want to succeed 5 times. I want to get a 6 5 times, and then for the other 5 times, well, I don't get a 6. And then calculate the job there. Also, there are tables on the calculator that I would like for us to be able to use. And we can go on the white calculator on the FX991EX class Wiz. Get on the menu, number 7 on the menu is distributions. Press equals on that. You'll have to go down to binomial CD. So press down and then go to binomial CD. And then if you click variable, which is number 2, you click variable, which is number 2, and then you can put your value of X in, your N and your P. Now this will give you the probability that X is less than or equal to a value, and that is quite important there. So if you want the probability that X is less than or equal to something, then you can use that on your calculators. Thank you.